Questions about anything we've talked about up to this point? All right. So now, finally, we're going to do table parsing. And we're going to use show IP OSPF neighbor. Now, table parsing is the simplest type of parsing, except when it's not. And I will elaborate on that statement in a minute. So show IP OSPF neighbor. And no, neighbor is not spelt with a U. America forever. All right. And yes, I am trolling you guys a little bit. All right. So let's qualify this before I forget. All right. So we're going to make a table parser. And so when things are simple is when the header row is nice and simple and it's formatted like this. Some operating systems will make their headers for the tables very beautiful and pretty with kind of almost ASCII art and delimiters and stuff. And that's great for humans, makes it easier for us to read them. But for machines, it actually makes it harder to parse. So just be aware that that is a thing that happens. So what we're going to do is we're going to make sure we've got the column separator field active, and we're going to select the header row and then copy it into column separator. And what it does is it looks at the header line, and anything that has more than one space between it is assumed to be a separate column. So in this case, it correctly separates it into the 6 columns. But what if we had multiple columns that were kind of squished right next to each other, as in show IP interface brief, to take an example? So in that case, we would need to go in and edit this, and you notice the semicolons are delimiting where the columns are, so we would just need to add or remove semicolons as needed to correct its misunderstanding. And there are some other things that we can do. We can choose the alignment method. We can say where the parser ends. So by default, the first blank line is the end of the table. So that's what $$ means. But if we have a table that might have blank lines in it, we're going to need to define an alternate way of saying what the end is. We can also tell it to skip so many lines after the header. So if we have one of those situations where there's like a row of dashes below the header row, we could just tell it to skip that. You can tell it to do what I call IBID from my liberal arts background, where if, you know how some tables, if it's the same as above, it's just going to leave it blank. We can tell it to account for that. We can also give it specific static lines to exclude. So between all of that, we should be able to sort out just about anything. But if you are experiencing issues with a particularly stubborn show command, do let us know. I should mention, we have a whole team of people that does nothing but make integrations and build parser files and so forth. It is a paid service that we offer. But while to have them just make stuff for you is a paid service, to get advice from me and my colleagues in the education team, and to get colleagues indeed from this team of experts here at NetBrain, advice is free as far as it goes. So if you ever have any questions, just go on the NetBrain Exchange and ask, or just email education@netbraintech.com. And like I said, you know, advice is free. If you want us to build something for you, that costs money, but there's a big thick line between those two, so you're never going to wind up getting charged out of nowhere. And in fact, we wouldn't build anything without a contract in place, so no worries. All right, so we've got all this, and now we need to define our variables. So we've got our columns defined, but now we need to define our variables. We can only define as many variables as we have columns. So in this case, I'm just going to click the plus sign 6 times, and here we go. You don't have to define all your columns as variables. So there are some times when you wouldn't want to, such as if you have sort of a dummy column to take advantage of like a splitter character or something, I don't know. But in any case, and you can choose what their names are, what their types are, etc., and so forth. So let's go ahead and save this. And I just realized that I have completely forgotten for this and the previous parser to explain for parsing that results in a table of data, there's something very, very important that I totally forgot to talk about. So let's do that. And this is tagging, or key tagging, I should say. So we see anytime it doesn't matter if it's a table parser, a paragraph parser, a collector parser, anytime that the parser results in a table of data, we have to define key values. We do this by going into the dropdown for the appropriate column and tagging for interface key, for table key, or both. Now, what the heck am I talking about? Let's start with table key, because this is a universal concept that has nothing specifically to do with NetBrain. All database tables need a key value, either explicit or implicit. The key value is the column that is going to guaranteed to be unique always in each row of the table. And it is used by the database to identify one row from the next within the table. So in this case, we can be confident, I would hope, that each interface is going to have a separate name every time this is pulled. So let's make this the table key. And we'll see we've got
the MAC address. Is it not going to be duplicate keys with different outputs that are parts, different switches? MAC addresses are unique.
I don't know, but basically anytime we pull a show int command from iOS, at least I would hope that we're not going to have two different interfaces with the same name.
So just unique per device that you're parsing, not across
Correct.
all devices.
Yeah, no, unique for this output of this show command.
Right.
Yeah, it's
so,
a local
sorry, I
key
didn't make that
rather
clear.
than a foreign key or anything like that.
Say what?
It's a local key to the table rather
Correct.
than something like a foreign
key. It is not a global key. It is a local key. So it's just for this table that's being generated into the adaptive automation, this table of data, it's a key for that specific table at time of execution, and then the table's going to get dumped after it's done. Now the data that is going to get put into the database has its own key structure, its own table structure. We don't need to worry about any of that. That's auto-defined based on this. And so that's a table key. And that's, I believe, a universal concept in any database ever made. Now, the other type of key value is unique to NetBrain, and it's called an interface key. And this is just to say to NetBrain, hey, this variable is the interface name. We may have one, we may not. It may be the same as the table key, it may not. So it's not actually mandatory to define the interface key. It's not like anything's going to break if it's not present. What it does is for certain things, in particular for building QApps, it will automatically populate the interface value into appropriate fields where possible. So there's that. All right, so in this case, it's both the interface key and the table key. So let's go ahead and save this.
Just curious, wouldn't you want to split off the Ethernet part from the actual numbers here as the key? So you get 0/0, 0/1, and so forth instead of Ethernet as a prefix for the interface key?
I don't see why it's relevant because the value is going to be unique. So as far as the table key goes, it's, each of these values is going to be unique. So that's what's important. Yeah. I suppose you could using regex or something, but again, we're dealing with this. Typically, it's just the name of the interface rather than specific types. So if we wanted to later only look at our Ethernet or fast Ethernet or whatever type of interfaces, we would filter the table within the adaptive automation to exclude rows that weren't relevant to what we want to do at the moment. So remember, the analysis is not being done within the parser. The parser is just to get the raw material. So let me put it this way. The parser is getting the ingredients from the grocery store. All the cooking is done in the adaptive automation building. So we're just concerned with the raw ingredients here. Hopefully that makes a bit more sense. All right, and then in this case, our neighbor ID is going to be unique. So let's set that as the table key, and then the interface is our interface key. Now, this may not necessarily be unique, but it is the associated interface name, so that's fine. The interface key does not have to be a unique value for each line. All right, and that is parsing, or at least as far as we're going to go today. So any questions about anything I've discussed up to this point?